All right, we have problem 23 of our calculator section of the ACT. So, I'm actually recording this late, so if I misspeak or I'm talking too fast or too slow or something like that, it's just because I just finished watching the Florida game. I was really sad that Duke lost. It's fun to watch Cooper Flag, and they're a really fun team. I think they're a really, really good team, and the refs absolutely blew that call. So that's where my head was at. So anyway, disclaimer. So here we have a right triangle, and it says for the triangle shown, which equation is not true. So the best way to verify questions like this is by process of elimination and figuring out which things are true, which things are always true. Immediately you see a right triangle, you think a squared plus b squared equals c squared, our Pythagorean theorem, but we see all of the answers have trigonometric functions like sine and cosine. So we know that we don't need Pythagorean theorem for this particular problem. So anytime you see a right triangle, first thing, Pythagorean theorem, that's the first thing you'll be tested on. Second thing, immediately you have to go to SOHCAHTOA. So again, SOHCAHTOA stands for sine, cosine, tangent. Well, just tan, right? So then the O and the H stands for O over H, adjacent over H. So the O is opposite, hypotenuse is, H is hypotenuse. So opposite over hypotenuse, adjacent over hypotenuse, A over H, and then opposite over adjacent, or O over A, okay? So three separate functions, okay? So we have our angle X. If we were to use some function, the best equation to use would be the opposite over the tangent, or opposite over the hypotenuse, right? Because this is the opposite side, the one directly opposing it, and our hypotenuse is the side opposite our right angle. Always for a right triangle. The opposite of right angle, that side length is our hypotenuse. So this is H. For this particular angle, this is H. For this particular angle, this is our opposite. Remember, if we were using this angle up here, like we call that Y, for example, this would become our opposite side here. And this would become our adjacent side. It's about the angle orientation and which one we're talking about. We're talking about X. So orienting ourselves correctly means that O is over here, H is here, and A would be down here. Our adjacent side, the one closest to it, that's what adjacent means. Like a door, it's opening, it's adjacent. So let's think first of all. Opposite of our hypotenuse is sine. So sine of X should equal, before we even do anything, 42 over 59. You can just write that right on here. Sine of X equals 42 over 59, because that's what we use our trigonometric identities. I'm thinking about making a video just on trigonometric functions and how to apply them, especially for right triangles. So or how to approach problems like this and find, for example, angle measures using supplementary angles, complementary angles, alternate interior angle theorem, stuff like that. If you guys are struggling with stuff like that and want to see a video, please comment that and I will definitely make a video on it, because it's been something that I've been meaning to do, but I don't know if you guys want to see that or not. So we know that sine of X does equal 42 over 59, so it cannot be option A. Remember, we're looking for the one that is not true. This is true, so it cannot be this one. Double negation. So then we have sine of 90 minus X equals 42 over 59. Now the rest of these have this 90 minus X, so it's important to remember that for a triangle, we have 180 equals the sum of all of our sides, all of our angles, excuse me. So if we have angle A plus B plus C, for example, then 180 equals the sum of all of them. But we know that this is a right angle, so it's 90 degrees, which means, let's say A is 90, A is our right angle here, that means we have 90 equals B plus C. We already are calling this X, okay, so let's say we label our angles like we were talking about. Let's say A, B, C, okay, let's call XC. When we substitute in C for X, we can see 90 equals B plus X. This is just the mathematical representation. I'm gonna talk through what it looks like visually too. So 90 equals B plus X, which means when we isolate B by itself to find whatever this angle is, we subtract X, right? To get 90 minus X equals B. So all this is 90 minus X, putting into context, it's just this angle up here. This angle up here is going to equal whatever our trigonometric function is. So the easiest way to think about that as well is if this is 90 and our triangle out is 180, these two added together have to be 90, right? So then if we just subtract the other one away, we're just undoing the operation. We're just finding out that the sum of these two equals 90, and we're representing it like this. So that means that this angle is being represented by this formula here, this inside the parentheses. Same thing as before, just looking at it visually and just kind of conceptualizing it. So now that we know that, we can go even further. So we know that this side length is unknown, for example. So any cosine any sine that has a value here, because for b, this turns into a, right? Or for b, this turns into a, and this turns into o. I'll write a little marker for you. Okay? Because this is the opposite side now for b. Remember, it's about the angle's orientation. We're looking at where these sides are in relation to our angle. Because it's opposing, this side here is opposing this angle, this is the opposite side. This side becomes the adjacent side when we're talking about angle B. It's the opposite when we're talking about angle X, but it's the adjacent side when we're talking about angle B. It's the adjacent side when we're talking about angle B. Okay, so knowing that, right off the bat, if we have something like a number for sine, that can't be possible because we know that the sine of this should be an unknown number too, because it'd be adjacent or hypotenuse, so it should be like a y or a z or something that's unknown, or just this a here over 59. But we see that sine here, it gives us 42. So let's think about that. Two things also can't be true. So we know this one's suspicious right off the bat based off that. But we also have cosine of 90 over x, 90 minus x equals 42 over 59. So those can't both be true unless these are equal. If that could be possible, but that would mean that x equals b, because then we have our isosceles triangle theorem. One more thing you could do is you could use your calculators to double check and make sure they're not both true, as my calculator has a conniption, by doing our Pythagorean theorem. So we'd have, let's set it up on paper first. We'd have 42, always a Pythagorean theorem, it's always important, 42 squared plus our side here squared, remember our leg plus our leg, the squares of those, are going to equal c squared, which is always the hypotenuse. We'll call this side length z. Z squared equals 59 squared. So z squared equals 59 squared minus 42 squared, just subtracting off the difference. Then not z squared. Z, we undo squares by doing the square root, equals the square root of 59 squared minus 42 squared. And that we can put directly into our calculators. We have the square root of 59 squared minus 42 squared. We see that's 41.43, so they are not equal. They are off by at least a little bit, which means that these two things cannot be true. So you don't even need to write the answer for it. You just need to know that 41.43 does not equal 42. They're close, but they don't equal each other, which means that these two angles must be different, and this cannot both be true, which means our answer, the one that's not true, is going to be sine, because we know that this would have to be 41.43 over 59. And you don't even have to go to this answer down here. Answer is